Well, hello, Cinemeric Nation, and welcome to another one of the Siemens webinar series. Today, we're going to explore the world of the machine space model specific to SinuTrain. So before we get into that, let me introduce myself for those of you that may not know me yet, but we will soon become friends, I'm sure. My name is Chris Pollock. I manage our technical application centers for Siemens, and I'm pretty much a what I would consider a product specialist on the Cinema control. Oops, got a little too fast here. Um, so with that being said, I specialize on a lot of the operation and programming based topics. We certainly have a wealth of knowledge and people within this organization that support the control from a service and commissioning side. Think of me, myself, and my team. We tend to specialize from the operation and programming topics. So if you guys ever need a hand, you have some questions, or just need some help navigating the world of Siemens, which certainly can be questionable or challenging at times just because of the size of the organization, you can always reach out to me. I would say best scenario would be shoot me an email, but if you get in a bind, you can always try giving me a call as well. So before we get into the topic here, I do want to just kind of show you some extra resources that you guys can use in the future. If you're not familiar with it, you're going to want to take a look at our CNC4U website. This is kind of the main landing page for all things Cinemeric from an operation and programming perspective. On that, we do have all of our webinars like you're in right now. And we have a complete library of webinars. So if you're looking for information, I would say go back, click on our webinars tab, and take a look at our past webinars. We've got a library of probably 70 or so. I don't know. There's a ton of them out there, and there's been a lot of topics we've gone through over the years. So you'll probably find that a lot of the questions you're looking for, we most likely already have some video content supporting it. You can also find out about our training classes on this website. So we're still in the midst of waiting to open up our in-person training. Hopefully that's going to be coming any day now, but we are been doing a lot of web-based training and we'll continue to do that. So you can find those training classes and information on them right on that website. Here you can see there'll be 3 primary tabs: our in-person, online, and then we have some web-based modules as well. So the online is instructor-led, multi-day training sessions, and we go quite deep into the product. So if you're looking for a training resource, I would certainly suggest taking a look, seeing what we have available. I think we have 2 classes right now coming up: G-code for milling, and I think another one, G-code for turning. But we're always kind of replenishing it. So check it from time to time for sure. The other resource I would say you guys want to take a look at if you haven't seen it before would be our Mr. CNC YouTube channel. So there we do a lot of different stuff. You'll find we do a lot of little video segments, promotional videos. We have a YouTube live series. So if you guys haven't seen that, come check it out. I try to host a live event every month to 2 months. I mean, I wish I could do it more frequently. Time is always challenging, which I know a lot of us run into that scenario. But certainly if you haven't been to it, go take a look at the Mr. CNC channel. I just did a fun one actually earlier this week on broaching. Or was it last week? I don't know, these weeks kind of blend together. So we did a little broaching. I created a custom macro to do it. So if you haven't seen it, head over to Mr. CNC, take a look. And then the other service we have that can be very helpful is our virtual product expert program. So there you can actually schedule a time slot to have a session with one of our product specialists. Danny Vitullo is managing the program, and he'll pull any one of us in to kind of run the segment. And basically at the end of the day, what it is you block out an hour time. We do an online interactive demo. We bring up SinuTrain, and we can go through all kinds of topics, but driven by your interest. So a lot of customers will use it from a training perspective. Other guys will use it for sales. So maybe they have a new prospective customer and wants to understand a little more about Cinemeric. So by all means, if you're interested, take a look at this. What you want to do is go right to CNC4U, right on the CNC training there. Oops, there is a virtual product expert link. You click on that, it'll launch the page for it, and you can actually put a request in for a segment or a session, and then we'll schedule it up at your convenience. Okay, so right now we're concentrating on two primary controls. Now we're doing it from the perspective of SinuTrain, but a lot of people don't realize SinuTrain really supports the 828 and the 840 control. So if you're looking to kind of create a twin of either of these variants, you can absolutely use SinuTrain as a solution there. The one it does not support is 808. 808 has its own offline programming package, which is kind of a watered down version of SinuTrain. So you won't be able to do everything I'm showing you today in the 808 on PC variant. But certainly if you have an 828 or have an 840 and you're looking to kind of take SinuTrain to the next level, that's what's going to lead us into the topic for today. And the topic is creating a machine space model. So a lot of you guys have seen me use these machine space models in demonstrations, product demonstrations, webinars for sure. And I've gotten a lot of requests on how to build them, if I've ever done an event that talks about building them. So there's been so much of a request that here we are. So we're gonna record this, we're gonna teach you. Now the concept here is to be able to get to the point where we can kind of conceptualize machine motion and a machine space model for SinuTrain specifically. This is using a more advanced feature, which we call collision avoidance. So if you are a commissioning engineer, this is only going to take you about half of the way there. Certainly there'll be a lot of great material leading up. So if you are an engineer that's looking to actually apply this technology on a real machine tool, this is going to help you there, but this isn't everything. This is specifically designed to get us to the place within SinuTrain where we can conceptualize machine motion. From there will be some extra steps. So just keep that in mind. But a lot of this stuff will get you started down the road. Now, whenever I kind of take on a new project, I like to kind of map out what the overall progression, here I'm calling it the steps to success, would be, so I can kind of stay on track when we build this stuff and I'm kind of designing it, right? So I would say first step is you do want to create yourself some form of a CAD model of the machine assembly. This does not have to be done in CAD. You could certainly take a piece of paper and start scratching out, but you do want to figure out what is the dimensions of the machine you intend to model within SinuTrain. If you do that, it's going to keep you on track. If you do not, it's very easy to kind of get lost in the weeds as you're trying to build up this kinematic chain and add in all these primitive components and where their offsets are coming from. So I'm going to show you the machine we built and kind of how we did that. But I do strongly recommend take the steps in the beginning. If you're modeling a physical machine, walk out to it with a tape measure, measure up the table, measure where the head is, get an idea of what the spindle cartridge size is, figure out where is machine 0 and what are our gap distances, right? If machine 0 on my Z is at the top of its positive travel, well, what's the distance from the face of the spindle to the machine table? Now, those are all things you're going to need to know. We will be activating collision avoidance license. We are using collision avoidance as kind of the portal or the option to allow us to activate this type of functionality. I'm going to show you guys how to map a folder because certainly for time restraints, I'm not going to go through every single machine data you have to set up. And in fact, for those of you that intend to do this in the future, I'll happily share the machine program that's going to set up all my MDs for you. So we'll do that. We will talk about the machine MDs a little bit, and then we're going to jump right into it. We got to create a chain. Once we've created the chain, we're going to add in some what I like to call primitives. So these are basically blobs of rectangles, circles, whatever, cylinders that will represent the machine. Certainly then we're going to test our motion, and then at the end we're even going to go to the next step and import some work holding that was actually downloaded and created externally. So now we can get to some more elaborate kind of geometries. So as I mentioned, step one, map out or lay out what you want to build. So for this case, I said, you know what, why don't we build a pretty standard machine tool that we would see in the market or the industry? And we're going to build a 4020 C-frame vertical machining center, simple 3-axis mill. So what I did was I jumped into NX. I started creating these basic components, a simple blob for my table, my saddle, my base, my head. I built it. I literally assembled it in NX. And then I was able to define where all my positioning data was. So now I have something tangible to work from. Like I said, if you're not lucky enough like I am to have a piece of software like NX, you can scratch this out. I will have to apologize. I'm going to cough a little bit today. I've been getting over a cold. Excuse me. So just bear with me. I downed some cough medicine just before the event, but I don't think it's helping too much. Ah, nothing worse than a summer cold, you know? All right, let me just grab a cough drop here and we'll get moving. So that's the basic design. Now, this is a fictional machine. Certainly there would probably be a few differences if I was actually producing this as a mass-produced machine tool, but it starts to get the concept down pretty well. So we got a 40 by 20 travel, 20 in the Z, basic table dimensions. I made my table match my travel. Saddle certainly a little bit narrower. And then I wanted to give myself enough of a gap distance, right, spindle to nose, my total throat. So I got 20 inches travel plus a 4-inch gap distance, which is pretty common, right? I wouldn't want my nose to touch my table. I'm always going to have a tool there. A lot of machine tool builders don't even allow you to touch the table with a standard length tool. So this is the machine we are going to build. Now, step one, we're going to need to create a machine, and then we're going to have to activate our collision avoidance license. Now, what's nice about SinuTrain is all options are licensed in it. Now, what we're going to do today, I'm using a full license version of SinuTrain. If you wanted to do this and use the demo version of SinuTrain, you actually could. When we get to the step of setting up all the machine data, you would have to go in and modify each of those ones discreetly, because there's no way to bring programs in or out if you don't have a full license. Certainly, if you're using SinuTrain, might be a good reason to get a full license version if you don't already have it. So let's start right off the bat building something up. So for me, I'm going to launch SinuTrain, which I already have power up. I'm looking at, now I have a lot of machines in my desktop, my workbench here. You may not have any here, but what we're doing is we're going to work from our machine templates, right? So we got a use template under create new machine. So this is what we're going to do to build up the files. Daryl just asked, I just saw it pop up, if we're going to talk about using STL files. We will. We're going to use STLs in the very end when we bring in our work holding. So just stay tuned for that. But first, we are creating our template machine. So I'm going to want to use the vertical milling machine as opposed to the demo mill. Demo mill is fully functioning, but there are things that you're not allowed to do. You're not allowed to manipulate machine parameters and whatnot. Because the demo mill, you can actually import and export programs. For us to turn everything on, we need to be in the vertical milling machine. Now, this is just a simple 3-axis machine. You could obviously get more elaborate with that if you wanted to. Okay. I'm going to give it a resolution that gives us, maximizes our screen display. I'm going to use 1366 by 768. Click create. Oh, I already got that machine. We'll call this our webinar EMC. So one thing when you're building machines, you can't have two machines with the same name. Okay, so we built up a machine. We're going to launch it, fire it up, and we're going to get our collision avoidance activated first. I always like to do that initially because we will have to do a cycle power whenever you turn on a license. So let's get this fired up and started. Now, as I'm going, for sure, if you guys get questions, throw them into either the chat or the Q&A, If I can, I'll grab them and we'll talk about them immediately. If not, don't worry. We're going to do a Q&A session at the very end of this. So either way. All right. So she's coming up. Of course, when I'm waiting on it, it's kind of like watching a watched pot boil, right? Seems like it takes forever, but she will fire up here in a second for us. There it goes. Usually that's that first initial power up when they've created the machine. Takes a little bit longer than when you start running them because it's building a lot of backend files at that point. Excuse me. I will be apologizing a lot, I think, today. All right. So we're going to fire up SinuTrain. When I want to turn on licenses, what you're going to need to do is you're going to need to hit your menu select key, jump over to setup. Now, what's nice about the template machines, I don't have to mess with the access level because they automatically come in at manufacturer. If you're using a different machine, you are going to have to activate the manufacturer level password to do a lot of the stuff we're doing right now. Expand your horizontal keys over with this arrow key to the right of optimize and jump to the licenses button. And this would be the same steps even if I was on a machine tool where I was going to activate a license. Now, what we want to do is we want to click the vertical soft key, all options, and this will give us the entire list of options available to me. So yes, you can start scrolling and looking. You can certainly use a search for collision. Quick way to get there. Nope, I don't want that one. Let me continue on and I get down to where it says collision avoidance. Now, there are three actual variations of the collision avoidance license and option. We're going to do everything in this first one, this AS02. So eco would be reserved for machines that we're not going to bring in STL files on. So certainly I wouldn't want to use eco. Eco is the only version you can use on an 828, just as an example. But that's an 828 on the physical machine. Here I can build an 828 inside a SinuTrain space and still use the full collision avoidance. Advanced, that requires a whole separate IPC or a separate industrial computer. It uses a piece of software from ModuleWorks that partners with us. Very elaborate version of collision avoidance. You'll see it on some very high-end machines, but everything we're doing today is going to be using this standard collision avoidance 0AS02 option. So all I need to do to turn on any license option is check that box. Now, if I was on a real machine and I didn't have a checkbox here, then I'd have to turn on my temporary licenses to be able to activate it, or I'd lose cycle start. But in SinuTrain, you see, I have all this stuff's already licensed for me. So now, just do a quick machine restart. I do like to use that restart over a reset PO because that will reinitiate the entire HMI. Steve asked a question here while we're waiting for this to reboot. If the Machine CAD files are available from the machine tool builder, it's going to really depend on the builder. A lot of them do offer kind of kits or packages where you can get all of these files. Everything we're doing today is with primitives, so we're not going to need any CAD files of the actual machine. I do some advanced machines where you see like all the fancy ones of my VTAC mill. Those would be driven from an STL. So when I reboot and I fire it back up, one of the first things I'm going to notice that's going to kind of acknowledge that collision avoidance is activated is I'm going to get these little sunglasses and this little kind of arrow and bullseye. If you ever walk up to a machine that has that, it says it has collision avoidance. For our purposes here, that's just acknowledging I turned the license on. Haven't done anything, there's nothing to see yet. Just turn the license on. All right. Let us jump back to our slides. Okay, so we've restarted with the license. Now we're going to want to map a drive. Now this, again, this is a step that requires me to have a full license version of SinuTrain. But this makes it really handy whether I'm inside of a machine that I built or I imported an external machine, something that was maybe built by my OEM that you possibly purchased. You can now move files in and out. So I'm going to show you how to map a folder or directory real quick because we need it mapped. So the way it works is back in the machine tool, I want to do a menu select, setup, and I'm looking for the HMI button, Human Machine Interface. So when you select HMI, on the vertical soft keys, you're going to see a button called Logical Drives. And by selecting Logical Drives, I can now change the buttons that I see in Program Manager. And that's what's key. What you're looking at here, this series of horizontal soft keys, these are the buttons you see when you hit the Program Manager screen. Right, so right now in Program Manager, I have NC Logical Drive, and if I plug a USB stick in, I'd get the USB, but I have no other map directories. So inside of this HMI area, I can now pick one of the empty buttons, one of the ones that doesn't say reserved, and we select the change vertical soft key. We click on the no drive and go all the way down to a Windows PCU drive because we're going to just map to a local folder on my PC. And now it's time to put in a path. So you're going to know where you want to map yours to. You're going to create some kind of folder. Just launch Explorer, Windows Explorer. Find the folder that you want to do. So I like to create this little folder I call programs. And I put a lot of stuff in here. And then where this little breadcrumb trail is across the top, click somewhere to the right of it and it'll convert it to the DOS path. And that's what we really need. So your path is going to be different than mine. The big trick here is copy that path. Excuse me again. Paste it in. Now at this point, if I don't leave anything, tell it anything else, it's going to call my button dev5. Doesn't really mean a whole lot to me. So I like to go down to the soft key text, name my button. So I'll call it mine programs. Select OK. It will now configure the device. I see the buttons created programs. So now if I go back to Program Manager, I have a quick way to hit an external folder. In my case, I'm going to be going into this little webinars, machine space folder. This is where I'm going to grab all my data from. That's a nice, fast way to create a simple tool to be able to move stuff in and out of SinuTrain. Because otherwise, SinuTrain's kind of like its own little sandbox. All right. So I mentioned earlier, I am not going to go through every one of these machine datas. Basically, what you see here on the left side, this is the bare minimum you would need to activate collision avoidance to use it for the tasks that we're doing today. If I was commissioning a machine for full-blown collision avoidance, there could be some more that I would have to set over this, but we are going to set these. Now, in addition to those few, we're also going to set some of the travels and a few other MDs outside of the collision avoidance. And this is because the machine we're using is just a generic template machine. So it has infinite travels. It hasn't been defined to be a real machine per se yet. We're making it behave as a real machine, so we're going to update some additional MDs. So these you'll see me, we'll do them directly. But how do I set all of those MDs? Well, I could certainly go to each of these machine parameters and type in that value. But what a lot of people don't realize is if you have the system variable, which the system variable can be copied right out of the machine parameter page, I can drop that in a part program and I can write it from a part program. So this is a real effective way of setting a whole bunch of MDs one shot. So I created this little part program. This is that file you were just looking at. I like to move it over and drop it in my NC folder. So that's what I'm going to do. And it's really as simple as clicking execute, loading it into auto, hitting cycle start. It's going to go to my program stop. I just hit cycle start again. That's an acknowledgement to me that I just set all of those MDs. What are part of those MDs? Safety distance tolerances, how many facets you can have for internal memory. There's a whole bunch of stuff here. Like I said, this is your bare minimum. So if you want to play around with this, shoot me an email. I'll be happy to share this file with you. Now, additionally, we have those couple extra parameters. So now I'm going to go to the actual parameter page. So menu select, setup, and go to your machine data horizontal soft key. And these are all the machine parameters. So what I was talking about with the system variable, these are system variables. I could go to any one of these variables and literally copy and then drop that into a part program equal to whatever number I want. It just wrote that MD. Kind of cool. So axis MDs, we need to give this machine some travel. So I'm going to go down to 36,100. And we're now going to set the positive and negative software limits. So in my case, my x-axis, you see the x-axis right here in the top right corner. I said I wanted a negative 40-inch travel. Oh, I don't want to set that yet. See, it's in metric. So I do want to change my unit of measure because these machines power up, and I'm going to have to actually rerun that program. I forgot to change the unit of measure. These are template machines initially power up in metric, but I figured we'd do this event in inch. So let me rerun that one more time because it was. Now it did have the unit of measure here, so I've probably been okay, but I prefer to make sure I ran it while I'm in the appropriate unit of measure of this part program. I'm setting a lot of machine parameters, so it could get a little funky on me. Now we can do the real travel, and this way it won't convert the numbers to some little tiny number. So I'm doing negative 40 inches in my X, positive 0.1. This way, when I start at 0, I don't get an over travel alarm. My Y-axis is going to be negative 20, as I said before. Give it a little bit of positive offset, 0.1 in my positive. Z is the same thing, negative 20, 0.1. So these are those other MDs that I mentioned right here that I am setting up. Now, the other two I need to do, I do want to do 34, 100. Now, this one in SinuTrain is where the machine starts when I first power up. So if you ever get a machine that powers up and it's like immediately giving you an over travel, it's probably based on this reference set position. You do not want to monkey with this on a real machine because this is how it actually datums and knows where machine 0 is. But in SinuTrain, you absolutely can play around with this one. So for me, all my travel is in a negative direction. So I don't want to power it up telling it it's at positive 20 inches because it's not, it can never get there, right? And then the last one is 53, 230. That's again, in this case, it says simulation start, but whoever wrote the tool change macro for this machine is also using this to drive it to tool change. I can never tool change a positive 19 inches because I only have 100 thou of positive travel in this machine. So I just set both of those to 0. This way they're within the working travel or envelope of the machine. Now, just like we did before, I do want to make sure when setting MDs, because some of them could be power up, that's what the PO designates. I make sure I do a quick little restart. And while that is rebooting, we can jump to our next slide. So we set our MDs. We gave it some legit travels. So I would say if you're making this kind of mimic your machine, use whatever travels and based on wherever your machine 0 is. So when I designed this machine, and real quick, we'll take a look at the part print. I designed machine 0 to be right at this corner. So all travel of all axes is in a negative direction. Your machine may not be. Your machine may have all the travels in a positive direction or a little bit of a mix. That's okay. But with that being said, you want to kind of keep that in mind when you set up all of your travels, right? I made mine match my conceptual machine. Okay, so once you've done this, you're ready. You're ready to start building what we refer to as the kinematic chain. So what is the kinematic chain at a very high level? Basically, it is a description of how the machine is made up, right? So if I walked up to a machine and I started taking parts and bolting it together to make up a milling machine, well, a standard C frame, like our little picture right here, this is comprised of some kind of a head and a spindle. All of this stuff rides on a Z axis. Separately to the Z, I have a saddle that is driven by the Y. On top of the Y-axis in the saddle, I have an X-axis, right, physical ball screw, and that's driving my table. This is the kinematics. So what we need to do is we need to describe this to the machine, to the controller. So we're going to do that by creating some simple offsets and then laying in our axes and kind of building up our machine. So that's what we're going to start to do first. So for us, we are going to initially start by navigating to the machine space model, firing up our tree. I'm going to show you that. And then we're going to build our first chain. So what I like to start with is I built 3 offsets. The first one is going to be called root. That was actually set up by one of your default MDs. They always like us to start it at root. I don't know if it's going to hurt you or not if you didn't, if you renamed it to root, but that was an MD they always had. So I always leave that first one at root. And then I like to build my separate offsets. So my root, I think of that as my head, my spindle. This is going to be my first chain piece. So any of the axes that would effectively move the spindle around would be found up underneath this root chain. Then I'm going to have the table. My table is completely separate to the spindle, right? In this case, I don't have, it's not like my table's fixed or anything. So I will have a whole extra series of offsets driven under this table. And then the last one's going to be my base. That's going to be something for me to display my frame offsets. So let's get these first couple offsets set up. We're going to start a new offset, and then we're going to have 2 parallel offsets. So in SinuTrain, what you want to do is you want to navigate, menu select, and setup, but we want to go into the NC button. And NC may not be a button that you've navigated in very often in the past. Under NC is the machine model button. And in the machine model, you're going to get this little tree. So anything to do with your kinematic chain is under active data. We do have some cool examples here. So if you bring up your graphics window, you can see I have a kind of a head-head kinematic example. We have a mixed kinematic example. We have a table-table example. So you could copy this example right up to active data, or you could build one. So what we're going to do is we're going to build one. Now, I'm not going to see anything in the graphics right now until I actually have something there. So when you're building these first couple offsets, you want to have your highlight on active data. You're going to tell it you're going to create a new element. And on the new element, the first thing we always do is an offset. Everything wants to build off of some kind of an offset. So say offset and OK. Now this auto named it as root. That was set up by one of those MDs that we set before. So like I said earlier, just leave it at root, but that'll be where our head starts to branch off. Now I'm going to create my other 2 offsets. And since the table and the base have no dependency on the spindle or that head, right, then I'm going to make them parallel offsets. So that's where I come to this parallel option. Click parallel offset, say OK. Give it a name. I'm going to call mine table. Be careful you don't keep reusing the same names. So I would say no matter what you're doing when calling an axis or an offset, there's a bunch of different things we're going to call. Try to avoid using the exact same name within this whole kinematic chain. We're going to do a third parallel offset, and that's going to be our base. So this just gives me the kind of the frame or the structure to build everything from. I like to design kind of the mechanics of the machine, and then I put in the blobs that represent the actual machine motion later. So that's what we're going to do. We're going to kind of build up the framework of the machine, and then we'll go back and we'll add some cool little features to kind of make it look like a machine tool, right? Okay. So we have our 3 offsets built. First one was a standard offset. The second 2 were parallel offsets. Now we're going to build up our first branch of this kinematic chain. So the first branch is going to build off the root, and that's going to be the head. So in my case, I think it reads a little better to actually have an offset here called head. And then the head is going to consist of an axis. So there's my z-axis. Another axis would be a rotary axis, a tool, and I'm going to want to build it in the way you're seeing here. So we'll put the head offset in first. Then we're going to go create a linear axis. And what's important is I understand what the naming nomenclature of my machine axes are. So that's what you see when you hit the machine button. And I'll show you that in a sec. Same thing, I'm going to create a rotary axis. It's going to represent our spindle. The spindle is just a rotary axis. And I want to use the same name. Now we do have to give it a direction of motion. So we're going to talk about that. That's this axis orientation number. And then we're going to plug in this tool data. And this might be a little confusing. What I'm going to say is you're just going to always use these basic numbers for certainly a machine that only has a single spindle. So this unit, this tool unit number, this magazine number, location, that's going to be a constant. So we will plug those values in. So as I mentioned, first things first, now go to the root. Now it'll auto fill out root colon table, even though I just created a root table in base. It's just kind of the way we have it, we do it. So don't sweat that. Click new element, and we're not doing a parallel. We want a dependency here, right? It's building on it. So I'm just going to do a simple offset. This one I'll call my head. And if I needed to move the head to some new location, I could then put an offset value in there. Once I have the head offset in, now I can actually define an axis. So new element, my head is going to ride, everything's going to ride on top of the Z axis. So I'm going to click linear axis, name it. I'm going to call mine Z_axis. Makes it easy to read. I do need to tell it the direction that this is moving in. Z-axis doesn't mean anything to this machine. Kinematic chain won't know that I should be moving in a Z direction. So that's where you will put a value of 1 or -1, depending on the direction of motion. For a Z, I'm going to put in that value under Z. For the Y, I'm going to put it in Y. For the X, I would put it in X. If I had a modulo axis, right, it's tipped at a weird angle, then I could actually have a value in 2 of these components. But everything we're doing is normal to the standard machine coordinates. You do need to tell it the true machine axis name, MZ1, and if you wanted any offset here. Now I knew this. If I got it wrong, it would alarm out right now. Now I knew the axis name because back here when I'm looking at actual values machine, it's really just the naming terminology that I see under this. You can also go to a machine parameter and see what the naming is. But don't use the XYZ. You need to use whatever the OEM or commissioning engineer called it when they assigned this base name. So MX1, MY1, MZ1, MSP1, that's what we need for the designing of the kinematic chain. So that's what kind of links it to the physical parameters of that machine. So we have our first axis. Now, if you remember from my little diagram, next thing I did was a rotary axis. So I'm going to pick rotational axis because that's going to be my spindle. I'm going to call mine spindle. Now, if you think your spindle is pointing in the same direction as Z, typically, so I'm going to put a +1. I'm going to type MSP1 for my name. Again, referring back to that machine screen. And then I need to create our first, what we call a collision element. So when you select new, you actually have a couple buttons here. We've just been doing everything as a kinematic element. So under collision element, you have 2 potentials. You have a tool or a machine protection area. So right now, we're just kind of inserting the container that's going to hold the tool. So say okay, give it a name, we'll call it tool. Some color I can assign for it. The important things here would be that it's activated. We want that to mean number 1. This should be 9998, and location should always be 1. So this you're going to always fill out, the 19998 and 1. So say okay. You now have a holder for the tool. And back to our little diagram, see this is where I got my numbers from. So activated is important, or it's not going to actually show that component. Detail level we'll play around with a little bit later. So this builds up the first chain segment, and then from there I'm now going to build my next piece of the chain. And the next piece of the chain is really going to be my table saddle mechanism. So what does everything ride on? Well, it rides on my y-axis. So I'm going to do the axis first. That's going to be sitting on the table offset. Then I'm going to put in a separate offset in between the y and the z. This would allow me, if I needed to shift the x-axis, I could. Not absolutely necessary, but I think it reads a little better and gives you a little more flexibility in your chain. And then I'm going to put in my physical linear axes for my X and the same nomenclature that we talked about before. So come to table base, select new element. We're going to go back to kinematic element. So this retains whatever it was last at. And the last thing I did was a tool element. So don't forget to hit this vertical soft key kinematic element. Once I'm there, pick a linear axis. We're going to call this our Y. Oops, I have caps locks on, so that's good. Now, the direction of motion in this case is going to be a -1. And this would be the time where I would ask the class, anybody know why we would use a -1? And the reason being is, so if it's +1, I'm describing tool motion, right? When we program, we always describe tool motion, right? So if I want to go take that tool to the negative direction, I tell it negative. If my y-axis was up on my spindle, I would be moving negative. But since I have a y-axis on the table, I have to actually send the table the opposite way, right? Because I'm programming tool motion. So this is why on a table-table kinematic, where I have my x and y not driving my spindle around, you want to invert the direction. If you get that wrong, it's really no big deal. You'll just notice everything will move backwards, and you can just change the sign. So my1, say okay. We got our first axis. Like I said, if I fat fingered this or wasn't thinking and just said, oh, it's my y-axis, then it'll yell at me and say, I have no idea what that is. You got to put the machine axis designation. Okay, reset, clear the active alarm. I'm good again, no red. New element. We're going to do an X offset. Now I am specifically using the term offset to keep me from using the same exact name. Remember I said try to not set two components with the same name. Now I'm doing another linear offset. We're going to call this our X axis. Same scenario. Got to use a -1 because it's my table motion right now. MX1. Okay. So we are just about done with the chain. So my last thing, I like to throw in an extra offset down off my base to represent my frame. Not really needed. But once we put this one in, we're really done describing the chain on this simple machine. So we're going to then do a reset, and you're going to see what the behavior is. Basically what it's going to allow us to do is now test our tool chain. So we're going to see this little coordinate. I can tool change tools in and out. We can start jogging some things around. So in here, as I mentioned, we'll do one extra offset. Call it my frame. It'll be my machine frame. Now we're going to do a machine restart. Let it reinitialize the HMI. Reset PO is a little quicker. With kinematic chain, I've had better luck doing a full machine restart. Usually once you get it all kind of set up, then you can tweak it, and you most likely won't even need to reboot. But we just built the whole chain for the first time, so it's good to kind of reinitialize the entire HMI. Okay, so we booted up, we're fired up. Now notice I don't have any tool in the spindle currently. If I was to go back to setup, NC, and machine model and bring on my graphics, now I get this little cube. So the blue dot is machine 0, or wherever the spindle nose is basically. So if I was to start to jog my machine, you see this is the distance I'm away from 0. I can jog the Y. Now it's hard right now to conceptualize the direction, but you'll see dependency. So this line is the x-axis. So you notice as I move the Y, the x now goes with it because I built the x on top of the Y. Since there's no dependency between x and y and z, when I move z, I just get the little bubble. But I now start to see motion, and this is what's going to drive my model all around. Now what's cool is if I now go and do a tool change, I'll jump over to TSM and go grab some tool. We'll use this nice big tool. So you do have to use positive tool length offsets for kinematic chain to work properly. So that's one thing to keep in mind. But now I'll actually see the black object. It's black because when I built my chain and I defined under my tool protection a color, I just left it a black. If you wanted this thing blue, green, or whatever, you could make this any color you wanted. I like to leave the tools as black. Don't know why. But now if I jog it, you're going to see the tool will move around with the z-axis. It's not going to move with the y or the x because that drives my table. But I can now get some concept of basic motion, right? It looks like I'm moving in the right direction. So this is when it gets fun. Now we can start to add in kind of some blobs, I like to call them primitives, within the system that would represent the components of my machine tool. So back here in our little slide deck, this is going to be the first thing I do. So I built up the chain. Now we're going to go back to different pieces of the chain and insert a few things. So what I want to plug in, and I like to work from the head down, I'm going to give a little cylinder to represent my spindle. Then I'm going to give it a little rectangular cube to represent my head. And I'm going to build it from the basically spindle face or my machine zero back. So I'm going to create a protection area, just like we did for the tool. This would be a machine protection area. You have to create that to get to the portion of actually getting to your primitives. So once I create a protection area, I'm going to drop something that's going to denote a cylinder representing my spindle. And then I'm going to create some blob. I'm going to call it my RAM. We got some offsets to put in, so I'm going to explain how all that works as we build it. So when I start to create the object, right, I'm going to come up here and I'm going to go to my z-axis, and now I'm going to do a new element, and I can turn off the graphics, give me a little more real estate. I can do a new element, and I can do a collision element, and I want to give it a machine protection area. So this is the way that I can get to the point in which I can put in some primitive features. So when I name my protection area, I usually always start with PA and then underscore and maybe call it my head. You can define some color. So maybe I'll say that my spindle is going to be this light blue. And I got to make sure I always remember to activate it. Don't worry about playing around with the PLC. The detail level will mess with that in a little bit later. So just give it a name, protection area, PA underscore, and what the component is. In that case, my head, and activate it in whatever color you want. Now, when you do this, it's always going to give you this alarm first because it's saying, hey, you created a protection area, but there's nothing for me to protect. I'm not holding anything. You got to get the next element in. Once you get the next element, then you can reset it and the alarm will go away. So on a protection area, I'm going to say new element, and now look what we get. We can build frames, which is just an offset. I can do boxes, make a cylinder, a sphere, a cylinder, a cone, or I can import an STL. So we're going to make a simple cylinder, and the cylinder is going to represent my spindle. Now remember I said I didn't want to use the same name, so I'm going to call mine spindle number 1, in case I maybe had a couple pieces representing my spindle. In SinuTrain, I like to just set this to display. There's no point in using up the resources required for monitoring. If you're actually doing a full-blown collision avoidance scenario, then you want to add in the monitoring piece. The dimensions of my object, well, that's where I get to my nice little handy print and I start to look. So my spindle, I said, is a 5-inch diameter and it's 5 inches out from the face. Now, the other thing I have to keep in mind is where the 0 is on the primitives, at least when I build them inside of these blobs, these primitives in SinuTrain, right? So give it some height, 5 inches, give it the radius of 2.5. I said diametrically it was 5. And now, if I don't tell it anything right now, I say, okay, I can reset that alarm, bring up my graph, I now get this little blob, but you see how the center of the spindle or the tip of the spindle is in the middle of the object? So this is the only thing and it's really why it gets helpful to kind of map this whole thing out. If I I have to take that into account. It's always going to work from the center of the object. So in my case, if I know this is 5 inches long, I want to shift the object in the positive direction half of the height. So if you go into the spindle and add a positive value in Z of 2.5 and say OK, boop, see how it now put the spindle face, because this is the spindle face, right? This is where my 4 inches of tool are projecting from. And as I jog, you're going to see the component now goes with it, right? Because it's all being carried by the Z axis. And if I was to take the tool out, and I go look, see the black goes away, but my little bubble is sitting there at the face. This is your connection point where you bolt in your tool. So that's why I had to shift it to get that point on the face of the spindle, or the nose of the spindle, not the middle of it. Now the next component is going to be our head, or our ram. So here I have a 12 by 25, and it's 12 inches high. And then we got to figure out an offset here. So this will be a little different because we're going to be working from 0, but it's building on top of the last element. So we jump back to SinuTrain. I'm on top of the spindle. I'm going to get my highlight back. Oops. Cancel. All right. So I'm on top of my spindle. I want to put a new element. It's going to be a box. We're going to call this our ram. Pretty common term. Now maybe I don't want to use the same color. You can click uncheck the from protection area, and now I can pick some kind of color. So I'm going to do maybe a darker burgundy. Yeah, I'll use that one. Why not? Switch it just to display like we did before. Give it my dimensions. So I said it was 12 by 25 by 12. If I don't put any offset, just like before, it's going to build it right in the middle, right? So now I lose my entire spindle, so I can start plugging in some offset to figure out. So I'll usually first try to shift some Z offset. So if I know this is 25, all right, well then let me at least go 6, half of the object. So now I get to the point where, okay, well I got that, but I still need an extra 2.5 because of the additional spindle. So maybe I go 8.5. And you can kind of, if you don't fully have your head around these offsets, you can just kind of start pushing stuff out until you see a gap, right? So if I look, boop, now I got a little gap there. So certainly I wouldn't want that gap. So that'll kind of verify or acknowledge your math as you kind of play around with how these things stack up. Now, as far as the X offset, I don't need anything because my spindle would be dead center of my ram, but I'm going to need some positive offset in my head in my Y direction. So if you look at your little layout and I look at the side direction, well, I see the center line of the spindle from the back is 20, but from the middle of the object, right? Well, I got 10, 10, right? And it would be, I'm sorry, 12.5, right, would be the center of the object less another 5. So that would get me to what I'm at, 12.5, 10, 8, or about 8. Let me see. I can cheat and see up 7.5. So that would be my offset shifting my head back. So let's try that, see if that makes sense. So we go to the y-axis, 7.5, oops. Say okay. And now you see it shifted it. So as you build it, just kind of keep that in mind that you're working from the center of these features, these blobs. But as you build it, now as I jog, everything's going to go with it. It's all going to carry with that head. And you're always going to see this kind of mustardy color on whatever item you're highlighting. Put the highlight back to active and you'll see the colors associated with everything. I can start to tool change in and out, and I'll see the tool now come back on the spindle. There it is. All right, so let's build our other objects. So back on our little PowerPoint, I now got to build up the saddle. And once we build the saddle, then we're going to go and we're going to build the table on top of that. So that's a little different because I have two different branches. So we're going to put the saddle on the Y, and then I'm going to put the table later down on the X. So we need a protection area, and we got to put in some features for moving our axis around. So move your highlight down to the Y axis. We can turn off the graphics. We're going to do a new element. It's going to be a protection area. I'll call this a protection area of my saddle. We'll assign some color. Maybe I'll use the same burgundy. Looks like my machine behind me, kind of like that. You get the initial, oh, I butchered the spelling of saddle. I added a Q in there. That wouldn't have hurt anything, by the way. I get the same alarm. It's no problem. Remember, I got to put some kind of a feature in. I'm going to put a box. This is going to be my saddle. And I like to always get in the habit of doing the O1, because what if I have a couple components building it up? Change it to display. Now my saddle from memory is 40 by 16. I think I made it 6 inches high. Let's see what I did. And I did. I made it 40 by 16 and 6 inches high. So I want to use that. And just like before, right now, if I say OK, we reset this and bring up our graphics, you see it now puts the saddle at 0. It is moving independently of the Z-axis, so it would move with the Y. But if we think about where the machine actually is, my saddle's not all the way up at machine 0. It's shifted. And it's shifted down. And keep in mind, I'm working from the center of the object. So, boom, boom, boom. I know it's shifted in Z by this gap distance of 24, by the thickness of my table, which is 4, and then half of its thickness, which is another 3, right? So 24, 28, what's that get us to 31? So let's try that. So let's go saddle, Z offset, and it would be a negative 31. Say okay. Drops my table down. It is centered in the Y, so that's okay. I don't need any offset in the Y. But right now, if I look at it, the way it's positioned, I would only be able to get my spindle to half of the saddle. So as I move away, right, I'm never going to get to the other side of the saddle. That's because I need a little bit of offset in the negative in my Y, that'd be my Y axis, sorry. So you look at your little design. Hopefully this is driving home the fact that you definitely want to lay this sucker out. So my center line, my spindle is the edge of the table. So I can't offset just 8. It's 8 plus how much this gap is. So if my table's 20 and these are all centered, and that's 16, so that means I have a 4-inch difference. That tells me I have a 2-inch overhang on either side. So if I shift it by half its width plus that 2-inch, so 10, it'll get me right there. So let's put in the Y, and that would be a negative 10. The beauty here is if you get it in the wrong direction, it'll just shift it the wrong way. But in my case, now look, my center of the spindle is just off the table. I start to jog, and I could get that tool on either side of that saddle. It's centered. I would buy that. Starting to look like a machine. Now, when it comes to the table, I'm going to want to jump down to the X offset and the X axis and now build my protection area for my table. So new element, machine protection area. A lot of redundancy here, right? So once you kind of get it, the first couple components, I think it starts to click. So I'm going to call this my table. Now, I don't want to call it burgundy. I want it more of a machine color, so I'm going to make mine gray. I want to make sure I activate it. Let's drop in our box to represent our table size. Name is going to be table. underscore 01. I'll keep the same color, just display purposes. Now, if we were to go back to my print, I had made my table 40 by 20 by 4. So I knew that. And then when I want to shift it, just like before, since this is not riding on top of the saddle 01, it's going to move it right back to machine 0. So that's why it's all the way up here. So we got to shift it down in the Z. Quick look at my print. So we got 24 plus half its thickness, so 26 will get me there. So I can do minus 26. Oops. That'll position me down. So I'm right on the surface. So now I just have to shift it, and I shift it in this case by half its width because the edge of my spindle, and I'm at 0, is going to be the edge of my table. So just shove it back in the Y a negative 10, half of its width, and voila. Now I have a table centered. And what's cool here is since that's dependent, right, I move my Y, my X moves with it. I move my X, it has no bearing on the Y. Now I have one other thing that's wrong. If you notice, I also need to shift and offset my X on the table because that's not right. I shouldn't be able to go beyond the table by half its travel. And that's because if you remember in the picture, when I'm at 0, my table shifted all the way to the left. So I also need a negative offset of its overall width of 40 inches. So let's jump back, give it one extra offset. And all of a sudden everything is getting weird, really kind of laggy on my PC here. I don't know why. All right, X, go up here, negative 20. Why is this so laggy? That's weird. And now it's going to shift eventually. There it goes. This is SinuTrain or this is everything. Let me jump over to my slides. Everything seems like crazy laggy. I don't know why. Here, let me do this real fast. Bear with me. I think it's probably WebEx messing with me. But I am going to cycle power on SinuTrain. If you don't mind, because I might be a resources thing. This stuff never happens when I rehearse because I don't have WebEx running. We got all kinds of stuff streaming. All right. Yeah, that seems a little better. Good. All right, let me fire up SinuTrain again, real quick. Okay, so now that we have our blobs in place and we're waiting for SinuTrain to fire back up. So my next thing after I added my table is going to be just add my base. And I like to plug in the base because it's just going to give us a little bit better of a spatial feel, shall I say, to the machine. Not required, not necessary. And sometimes what I'll do with the base is I'll actually in the protection area give it a detail level so I can kind of turn it off if I wanted to. Let's fire this back up. All right. So you can start to use that detail level that we've been looking at to show or hide certain pieces or components if you don't want to always look at them. Okay, so let's let her come back up. And we can put in the base. So the base, we get in front of this thing, 52 by 20 by 20. And then I'm going to have a column, right? That's going to be 12 by 51 by 20. So we'll just plug those in real quick. Same scenario applies. I have to just kind of calculate where my centers are off of my machine 0. We can cheat and use the numbers that we have here in the slide. Make things quick. That's where I got these offset numbers from. Just about back. You always know when it's going to come back because you'll start to get the lights on the machine control panel. We'll pop in first, and then it's just about to boot up. See how they popped in? And she's coming right back up. It's not a bad thing to at least shut down the machine periodically, 'cause some of this stuff actually saves on power down or of SinuTrain, or at least of the machine itself. So that's when it really writes to its backend files. So if you get like way into one of these things and you got a lot of hours in it, by all means, cycle power, at least on on the SinuTrain machine. This way you at least know, okay, I'm certainly saved at that point. Last thing you want to do is something happens with your PC and you lose all that work. Building these machines can get pretty involved. We are just scratching the surface of how far you can certainly go with them. All right, just about there. At least my mouse seems a lot better. So whatever was happening with my resources seems like it's come around. What I say about the whole watch pot boiling water thing is always fun. All right. So she is just about up. Maybe, maybe not. All right, good. Now, whenever you fire up SinuTrain, you want to give it your enables, give it your overrides. We're going to jump right back into the machine setup area here. Maybe, maybe not. What are you doing? Would I be surprised if Siemens IT was deciding to update things on my PC right when I'm doing this? Nope, not at all. Oh, there we go. She's alive, maybe alive. All right. This is crazy, 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 crazy. You're happy now? Set up. Come on, old girl. There we go. NC. Wow, it is laggy. Machine space model. Let's see if we can get through this. A little trick when you're highlighting your active data, if you hit shift and your asterisk symbol, it'll open up the whole chain for you. So we're going to build in the last components, which would be, I need a collision protection area, right? So protection area underscore, and we'll just call this our base. That's weird. Why am I getting feedback now? Bear with me a second. It's almost like somebody's, I don't know, do you guys hear that static? Because I'm getting some brutal static on the line. What is going on? Do you guys hear that? Do you guys hear some static going on? No static. Well, all right, I'm gonna go with it. Maybe I'm just hearing it. Um, Tim says a little. Okay. Boy, this is the day for technical issues. Okay, so our machine protection area, we just built that. I'm going to give it a little bit of color. Now, believe it or not, you can use white, even though white is the background, because you'll see shading. So sometimes it's something that I don't want to have a lot of visual aspect, I might create as white. So once we have our protection area element, we're just going to come in and put a simple box in. So the box is going to represent my base 1, we'll call it. We're going to want to just display it. I will go back and change the detail level, but I gave it some dimensions. I called mine 52, I think by 20 by 20. Let's cheat and grab my offsets. So I had originally calculated 20 in the Y and 35, oh, I'm sorry, 6 in the Y and negative 44. This would be on my first component. This one's relative to the other one, right? Because I'm going to stack them on top of each other. So we're going to go 6, 6, and I think I did minus 44. Let me see if that looks right. Oh, put it in the wrong direction. So it's 20 in the X and 52 in the Y. This is what happens when I try to speed up and I don't look at my print. But that just gives us a little kind of base blob. Now we're going to put in our next component, and we're going to call this our simple box. We'll make this our base underscore 02. Hence why I like to start with the 1. Just display. The dimensions on this object are 20 by 12 by 51. It's easy enough to do. So 20 by 12 by 51. Oops, not 514. Give it our final offset. So that was positive 20 and 35.5 because it's based now on this lower blob. That's where those numbers came from. So let's give it 20 and I think 35.5. Let's see if I was right. So if everything's right, there you go. I got a nice little blob. You can see how, move the highlight. You can see how the kind of the gray itself, you'll lose it if you're like right on it, but that white will still show up. So a lot of times I'll use that for a machine frame. Now I mentioned using this little detail level. So if you put a number of like number 1, number 2, then what you get on the system is you get under my graphic view, I get a little detail level button. So I got to that by expanding my vertical soft keys. So now I can turn pieces of the chain on or off. So I like to do that with work holding a lot of times because I may not want to always see it. Maybe that vise isn't on the machine anymore. So I can kind of toggle them on and off and they won't display anymore. Okay, so our machine is looking pretty good. Reset clears my last alarm. And again, turn your detail level on. I can start to move it around, get an acknowledgement that the machine spatially appears to be moving properly. I would buy that. So the next thing I like to do whenever I build these is I want to do some kind of a test, right? I want to run something. So we're going to do this because this will give you some understanding of where the offsets are coming from. Because this should now mimic, as close as I make it to the real world, my offsets and everything should all carry through. So for here, as I build it and I plug in work offsets for my part program, I'll be able to stage this part around. So let's take a look. So I had originally created and I had it sitting in my little shared folder. So my webinars, machine space model. So here's my little test program. So I'm going to drop that into my NC directory. Certainly going to run it from external. So this super simple program, right? I create a basic blob 6 by 4. So I'm using the top left corner as 0, 0. But I created it where my bottom of my part is 0. So this way you can kind of see a little better where the machine offsets are coming from. And then I just did a simple little face, nothing fancy. You guys have seen me do this stuff a million times over. A little rectangular profile so I can get some conceptual, right? So to start, without putting any offsets in, and one of the things you get now with the machine space model, under auto with simultaneous recording, you do have to be in auto. Under further views, right here, further views, you get a machine space button. So now I can bring this up. I also, under details, I get a detail level, so I can turn those things on or off with our little detail level. But as I start to run programs, you're going to start to see wherever it looks like my 0 is. And that's kind of interesting. Why would that part be back there? Huh. Do I have any values in my offset? I don't know. No, I certainly don't. So it should have staged that part. Let me try it again at my spindle face. Now maybe I fat fingered something. Oh, maybe because my table's not at 0. That's probably what it is, right? So let's put our table to 0, 0. So, no, I want everything that's sitting at machine 0. I'll be a 0.1, but close enough, right? And now let's take a look at where this part would be. Ah, there she goes. So you see the blue feature. So my datum is working from machine zero, and machine zero when I'm there is the top center of my table. So if I give it that offset, right, my negative 24, let's reset this, which is my distance from spindle face to the top of the part. And maybe I want to center it on its travel. So negative 20 by negative 10. Now my part is going to actually position, oops, rotate it for you, on the true space in the real world. We'll give you a little show path so you can see it. So you see how now it's mimicking and it's positioning exactly where I'd be. So that would be the exact same offset I would have on my machine tool, assuming I did this completely perfectly to scale. Um, this one was conceptual, but you could absolutely start to mock up your physical machine in this environment now, just with these simple primitives. And now you can see, do I have travel limitation issues? Am I going to have, reach or collision potential problems as I put different work holding or different parts on my table? It really gives you a much better conceptual than just seeing this, right? This is great. This looks wonderful, but I have no idea what my machine motion is going to be like. So by turning on that machine space model or our collision avoidance and adding the machine view, now I can really start to conceptualize what my machine motion is. All right, so there's one other thing that we're going to want to show you before we open up to um, some questions. Well, yeah, it's the craziest thing. I am literally getting all kinds of static from my audio feed. Let me just see something real quick, because it's driving me crazy. Microphone speakers. I don't need speakers. Ah, that sounds much better. All right. What happened with my PC? Let me just do a quick double check, make sure you guys can still hear me. You can. Wonderful. Okay. So, so we now have the part, we have a position space, we kind of verified that the machine motion's coming around. So what if I want to get a little more elaborate, right? What if I want to actually start to import some external STL files and then bring them in a fashion where I can actually have them inside my model? You don't have to start from scratch here. There is a world of available vices and chucks and all kinds of crazy stuff out there you can download. So I got this vice right off the Kurt website. It matches the Kurt vice that I use on my machine. So you can pull that down. Now you are going to need a CAD system to start to play with this, because there's a couple steps you're going to have to do that I'm going to show you. So first things first, you're going to want to pull it down. You're going to want to bring it into some kind of a CAD system. So I happen to be certainly lucky enough to have NX. And I tell you what, I am a big advocate for NX. I've really grown to like it a lot. So this is going to allow me to now bring this model in that I downloaded from Kurt. I can manipulate it a little bit. So what I did was I staged the adjustable jaw to a set gap distance that I knew I wanted. So I knew my blank was going to be 4 inches. So I already staged this. Originally, when I downloaded this model, this adjustable jaw was way back at the end. But the big trick here, when you want to start to bring them into our software, is you're going to have to export this as an STL. There's all kinds of software out there that can make STLs. But when you're going to build an STL, you got to make sure you build it as a text version of an STL, not a binary. There are two different formats in the industry. So like inside of NX, I can go to File and Export, STL, and you're going to see in the export wizard, I can do binary or text. It has to be text for SinuTrain to be able to read it. So use text. Certainly I can, let me just move this out of the way, come down, pick whatever object I would want to be exporting. So I could take components of this out. I don't have to have the whole model if I don't want it. Now, keep in mind, you don't want to have too many curved surfaces, because it's going to create those into facets. Flat edges are fine, but once you get into anything round, it's going to start to use up resources. So I like to play with my chordal tolerance and my angular tolerances to kind of try to get the model as small as possible without degrading too much of the geometry of it. So play with that. This model, once I put a pretty large value in here, 15 for chordal tolerance, 22.5 for angular tolerance. That ended up making this model about I think 1.3 meg. I could make this model come out at 20 meg. But all that stuff is going to use up resources on the control and SinuTrain while it's trying to run, and then you're not going to get a lot of value from it. So play around with the resolution, but just, say, okay, let it export. And then what's going to happen is once I have that file, in NX, I do have to rename it because for whatever reason, NX likes to actually give it a .txt extension. Even though it's a text file, it still has to read .stl in our world. So just rename the file to read .stl. And then what you're going to do is you're going to bring it over to the control. So for me, I had this STL file. There it is, this Kurt Weiss. So when you have the STL, and this is where you're going to need a full license version to bring the files in, but you can hit copy, navigate back over to the machine parameter area, but I want to come out of the machine space model and go all the way back to our system data button. And in system data, there is a folder called NC data. And in NC data, you get a collision models folder. This is the big trick. You have to paste the file into the appropriate folder. So you will need to know what unit of measure this thing was modeled in. So in my case, you'd think, oh, it's a Kurt Weiss, it must be an inch. Well, not really. So this was all modeled in metric. So if I came in, did a quick, dimensional check. Oh, come on, I gotta get to the edge. Where's my edge? On object. See if it gives it to me. But you see, millimeters. So just make sure it's okay. You can have a metric STL file in inch. You just got to make sure you put it in the appropriate folder. If you get it in the wrong folder, it's going to be scaled wrong. Once it's here, now I can bring it in and I can set it up. So here, I'm just like before, I'm going to add in a protection area. It's going to ride on my x-axis, but I'm not going to put it on the table. I could, but then the positioning of the device would be dependent to the table offset. I like to have the true dimensions from machine zero to that vise, at least to the datum of that vise, right? So the other piece of the puzzle I didn't mention here is there is some zero somewhere on this vise. You need to know where it is because now I'm not working from the center of the object anymore. I'm working from wherever the zero was. So I had the zero set at the center of this bore, bottom of the vise. So that's a real tangible point in space for me to position this. So I can add that -24 and it's going to put this vise smack dab on my table. I put in an offset half the table width, half the table length. It's going to center this vise perfectly, giving me some known position where I can spatially get that vise and then mimic it when I get out on the floor, right? So let's do it. Let's go back into our NC model, go back into the machine model. I'm going to come over to the x-axis, but instead of doing it on top of the table, so there'll be dependency on the vise to the table, I'm going to make a new protection area, machine protection area. This would be my protection area underscore, maybe I'll call it work holding. We're going to give it some color. I like to use the Kurt blue. I think it's appropriate. Maybe I want to add a detail level here. I could. I make it activated. And let's drop in the element. So I'm still on the protection area. I do new element, but now I'm not using a box or a cylinder. I'm using the file option. So select file, give it some name. So I'll call this my vise. Maybe I call it vise 01 in case I wanted the base vise and the jaw and that good stuff. Just want to display it. And now you're going to click on the file name. And since I put it in that folder, it's now available to me in the kinematic chain. If I hadn't copied it to the folder, I wouldn't see the model here. I can't browse anywhere. It's going to point to that folder. So pick it. Now, in my case, if I don't put any offsets, it's going to put that vise. Let's turn on our display detail level, right? See how it put the vise all the way up at machine 0? The vise will move around now. Let's reset it. So it's dependent on the axis. Oh, I'm in auto. Jog it around, right? I see it moving, but it's still position-wise its own 0, right? Which was the, oops, the bottom center of that bore. And there you'll see, there's the bore. You see how the circles now kind of come out like diamonds. That was the resolution that I built it at. So for me, I can come in here and now position it around. So -20, half my table length, -10, -24. It's going to put that sucker smack dab in the middle of my table. So now it just becomes a scenario of getting my workpiece to line up with my work holding. So this is going to be fixed in place, just like if I bolted it on my table. So if we go back to auto and we run our part, single blocks on. And I'm gonna have to turn on my detail level. All right, there it is. Oops. Do I not have my program? I don't know what program I have. Oh, cut test is there. Let me back out. Reload it. All right. There it is. So you see how my block itself is down in the vise? So now it's really up to me to take into account the dimensional data of this vise, right? Where it is. So I know I got 875 up off the table to get the bottom of my block sitting on top of my vise. So that can be just as simple as reducing the work offset by 2.875, my known thickness of my vise. As far as my X value, right now, if I move it over another 3 inches, right? So I can just make this 23 inches, half of the block. So the one I haven't figured out yet is my Y. But if we take a look at it now, you see how it's starting to position the block in relation to the vise. So just keep that in mind. You're going to have the vise is going to be fixed spatially by the kinematic chain. Your your blank for your cutting, right? Your stock model there, that is going to be dependent on the work offset. So now we could start to move. I could certainly take the dimension into account, or I could just kind of cheat a little bit and kind of fudge in the numbers. But now we can start to see the part starts to position a little more closely. Now I only moved it, I think, 2. In reality, it would be 2.837 would be to get that edge right up along the side of that vise. But now I kind of have a predictable position, right? So if I know where the vise is located on my actual machine table, I can position it here. And I just need to remember that to move this vise, it's going to be a matter of going into the kinematic chain, going down to the vise, and then adjusting the offset. So maybe it's -30 because I'm going to have 2. You could certainly have 2 of these things on the table, and you could mimic all of that. You can really start to create a digital variation or version of what you have happening down on the floor. It just gives you that much more, not only conceptual, but the capability of kind of getting in front of problems before you hear them down, wasting time in the machine tool. Okay, I want to say we had a lot there. I think that's it. Yep, we're ready for the Q&A time. So I've seen some in. Let me start taking a look at what was entered, but certainly if you guys have any questions, jump in, type in your questions here. So we got the STL, hopefully, Daryl, that started to make sense with bringing in STL files. We got Steve's question. Um, Okay, what version of SinuTrain supports this machine space model technology? So we initially came out with it in 4.5, but it really wasn't fully released in 4.7. So I would say you certainly would want to have version 4.7 or newer. What I just did all this in is our latest version of SinuTrain, which is 4.93. So I have three different versions of SinuTrain running. We did it in 4.93. All right. Switching to millimeter, will everything convert okay? Yes, it absolutely will. So once you build it, then you can bounce it back and forth. Now, I will caveat that with I have found in some of the more complex 5-axis systems that in older versions of SinuTrain, I haven't tested in 9.3 yet, that it may calculate the swivels and the Traore funky if I'm powering up in a different unit of measure than the machine was built in. But that is also machines that I built completely out of STL files. So I think it's a funky thing with the conversion of the STLs. So I would say if you get some weird motion and you know all of your STL files were in metric, power it down and back up in metric, and then switch your unit measure, and everything will be fine. Or just leave the machine in that unit measure and you can run the programs in inch. But these simple machines or these machines I've done with primitives, I've never seen that. I've only ran into that with these real heavy STL files that I use when I made my digital twin of my DMU50, let's say. Um, could you share the presentation by email? Absolutely. Just shoot me an email. I'll give you my email address again, and I'd be happy to send you guys out the slides. If you want the part program file, any of that stuff, I'd be happy to share. This session was recorded, and it will go onto the Mr. CNC channel as well. And everybody that was here, all you guys, will get a link to the recording. All right, what other questions do we have here? Let me look around. Can I import STL files for the machine? Yes, absolutely. It would be the same kind of scenario that I just showed you with the vise. So in place of putting in the primitive blobs, I would build it with the STLs. You will definitely need a CAD system for that because you will have to stage the machine at machine 0 and get everything positioned properly. So if you do want to go down that road, I would certainly say you want to be someone that's a little more versed in CAD and working in assemblies, but it can be done. Any way to have the vise linked to the work coordinate system? That's a great question. I've been trying to figure out a way to do that for quite some time. Fortunately, I've yet to find out a way. So no, you will have to make any adjustments to where the vise is in space inside the kinematic chain. Oh, and how would I add a fourth axis? Well, first of all, the SinuTrain machine you were in would had to already been commissioned for a fourth axis. But outside of that, you would create a rotary axis just like we did the spindle. It would be sitting on the table, and then I would have a few blobs that make it look like a rotary. There we go. Okay, hopefully I got to all the questions. If I missed anything, you guys have my contact information. You can always reach out. Hopefully you guys enjoyed this segment. I always enjoy doing them for you. It was great getting a chance to work with you guys for a little bit here. You need anything, by all means reach out and have a great weekend, great summer, and I look forward to talking to everybody real soon. So with that being said, Mr. CNC out. All right, we'll talk to you later, guys. Bye-bye.